All right, welcome everybody to the Gatton CNC Live. I hope y'all heard all that. When I went to play the intro, all of a sudden my speakers were disabled, so I just went ahead and assumed that y'all could hear it. I'm assuming that wasn't a problem on your end. It's just on my end. And of all the things I did the pre-check for, I didn't check that, and they don't work. But I don't need to hear anything, so it's all good. Hope y'all could hear it. And let me know if you can hear me okay with this mic. I see Eli. I don't know if I'm saying your name right. Says nice music, so I guess it worked okay. Anyway, this is the Gatton CNC Live. I do these every Wednesday afternoon at 3 p.m. Eastern. It's basically to try to help folks, particularly beginners, that are just finishing their build, or maybe they've only had it running for a short while, just to help the new guys basically, and anybody else might get something out of it too. But anyway, this Gatton CNC Live is brought to you by Paul. Paul, I don't know if Paul's out there. Yeah, there he is. I see him. This guy right here, I think Paul P. So he sent me an email the other day, and I've asked you anytime. This is y'all's show, so anytime you want to see something, just send me an email or whatever. Tell me what you want me to do or demonstrate, and that's what I'll do. But anyway, Paul writes here. He says, since I'm just completing my Gatton build, could you maybe cover suggested steps on what to do for first cuts with your machine and how to validate that it's running right? So thank you, Paul, for sending me that email. That's what we're going to talk about today. I've got a screen share set up, so I'm going to try to show a little of the machine, a little of the Mach 3. For the purpose of today's demonstration, I'm using Mach 3, which is what I normally use. However, I do have UC CNC, so if anybody wants me to do something with that, I can pull that up too as well. And I plan on doing that anyway. In fact, there's a lot of things I plan on doing as we go down the road. I've still got the Masso. I know there's not a lot of Masso users, but I will probably get back into that eventually as we get down the road too. So anyhow, let me talk about some of the first things you need to check really before you get all excited. I know when you get your build done and you may turn it on and turn the thing on. Of course, first thing you're like, oh yay, there's no magic smoke. So that's pretty cool. And then you just you poke a few buttons. I don't know if I can get over here. I got to get in the right screen. You poke a few buttons and you go, oh man, it's moving, it's alive, let's cut something. So you get a program and you get ready to cut, but there's a couple of things that you probably need to check before you just try to, especially if you're running on a good piece of wood. You always want to use scrap for that first few times to test it out. But one of the things you need to check is, as you're setting up your in this case Mach 3 settings, or whether it's UC CNC or whatever it might be, you're going to have hotkeys, so that which button when you push on here, which way it goes. So one thing you want to do is you not only want to make sure that when you push a button, what's moving, but you also want to know which direction it's moving, and make sure that the digital readout is also reading the correct way. So if I push the up arrow on this keyboard, that should move the y-axis back. So we can see that it does. That works. And let's also check if we move that. I'm going to move it that way a little bit more. We can see that the y, well, you guys would be able to if I show you, huh? Okay, so you can see, let me move it back a little bit. I got to keep clicking in this screen. Okay, so if I move the up arrow, you can see the y-axis moves back, but also the digital readout on the y-axis goes in the positive direction. So that's what we want. So if I bring the down arrow, it's going to come forward like it should. And also you can see that we're heading into negative territory now. So that one's working right. Okay, for the Z, most people use page up and page down. If you've got and I apologize because I keep moving out of the shot here, but if you got a keyboard that has a page up and page down, most people use that for the Z. So I'm going to hit the page up here. If I can, every time that's not wanting to move at all now. Well, why? Well, I just broke it, I guess. I love live shows. Let's see if anything else moves. Oh, I'm such an idiot. Okay, just like I was telling you, most people use page up and page down. But what I forgot to mention is typically when I'm running this machine, let me get over here for a minute. Typically when I'm running this machine, I'm using this keyboard, which I really like. It's a wireless, it's a Logitech, but one thing I don't like about it is it's got 4 arrow keys that work great for the X and Y. But in order to do the Z, you have to use a combination, which means you have to use 2 hands. So you have to use function and then either the same up or down arrow that you do for the Y. So what I did is I changed that and I made the hotkeys D and U. And that's why when I was pushing page up and page down on this, it wasn't doing anything. So let me now that I've got through that brain part, if you push the U or inside, you can push page up, either one. So D goes down, and you can see that the digital readout's decreasing. And if I go up, well, I gotta quit hitting that page up. There we go. So that one's working okay. All right, now, as you might guess, I've screwed one up on purpose just to show you here. So if I hit the right arrow key, this gantry should move this way. It should move from left to right. And you can see that it's wanting to move left. So I push the left arrow key, it's wanting to move right. So we know that's wrong. And now if I push let me push that left arrow key again, we can see that the digital readout is showing the negative. It thinks it's going that way, but it's going this way. It's actually going in the positive direction. So we know that one's definitely wrong. So I'm going to move this back here a little bit. And one way to fix that, there's a couple of different ways, but I'm going to show you the way if you're using a parallel connection or a USB to parallel motion controller like a UC100 or whatever. This is how you'll probably end up doing it. And you'll come up here to, let's see if I can swap that and make that bigger. You'll come up here to homing limits, and I'll just uncheck that reverse for the X. Now this won't work with a lot of other cards, and I'm going to explain that probably a little later on, but just for the purpose of this, the way I have mine set up, that's how I would reverse it. Yours may be different if you're using one of those different cards. But now I've changed that. Let me go ahead and save the settings here. And now flip back and make this big. And now let's see if I've got it going the right way. So now when I push the right arrow key, oops, I got to get over here. Clicking that, there we go. So now it's moving to the right, and you can see that the DRO is also increasing as it goes to the right. And as I move it to the left, the DRO is decreasing, which is correct because it's going to the negative side. Okay, so let me try to keep up with these comments here too. Okay. I don't see any questions, so I think we're okay. Okay, so you've got to make sure that's probably one of the main things you'll want to do when you first start. You got to make sure everything's going the right direction, your hotkeys are set up right, and that your digital readout is going the right way. Because if none of that is working, or you just have one thing not going right, you might as well not even try to run a program because it's not going to come out right. So that's probably one of the first things, you know. And now you might be thinking, well, I got that all fixed. Now let's run a part. Let's fire it up and run something. Well, let's check a couple of more things before we get crazy here. I'm going to bring the if I can get this tight, because this is screen share and I keep having to click in there to activate that screen. Okay, so let me bring this down a little bit close. I'm just going to take a tape measure because I want to see if the steps per revolution that I put in the software, I want to know if I'm even in the ballpark, because I might not be. Well, just to show you, of course, I've already screwed up the X, so I know it's not right. We're gonna show it. I'm just going to grab this tape measure and stretch it out. If I can get it to quit moving here. And I'm just going to try to. Okay, I've got the center of the bit lined up with 10 inches. And then I'm going to put an MDI command. And I'm going to set this little block right here so that you can see. Because right here is 30 inches. So if I go from 10 to 30, that would be 20. So I'm going to come over here. And I'm going to go to my MDI. Well, first, let me just zero everything out right there. And now I come over here to my MDI, and I want to tell it to go X20. First of all, I notice it sure is moving awful slow. So let's see how far it goes. It's got to go all the way to this block here. That would be 20 inches. And it stopped. Okay, the DRO, the digital readout, says that it went 20 inches, but it's pretty obvious that it's still, if we look, we can see that it stopped at 20, so it only went half as far as what it should have. So, assuming I've set the dip switches on my drivers correctly, and you want to make sure, you know, depending on how you do your settings, you want to make sure you set those probably the same for all of your drivers. So I know I'm only going half as far as I should. So I'm going to go ahead and click go to 0 on here. And you'll see it'll go back. And it went right back to the 10-inch mark where we were. So I know I'm not going but half as far as I should. So I'm going to come down here to motor tuning. And for this X-axis, I see that I've got 6,400. Well, that's only half as many steps as I need to get to where I want to go. So if I change this to 12.8, like that, make sure I got that right, and click OK. Wait a minute. Yeah. You have to hit, I was so worried about whether I had that typed right. You have to hit Save Access Settings first and then hit OK. Because if you just hit OK, you saw what happened. You go right back to it. It's still the same as what it was before. It didn't change anything. So I'll come up here and save my settings again. Now, you'll notice that my DRO got all crazy here. So I'm going to zero that back out. So I've got 0, 0, and 0. And now I'm going to come back to my MDI and put the X20. And now you see, oh, it's a lot faster. And it went right to the 30 where it should. Now, this is not an accurate way to calibrate. So this is just a quick way to eyeball it to get you, to see if you're in the ballpark. To see, because if you're not even, if it went from 10 to 18 or 28, which would be 18 inches, you know you don't even have, you're not even close. But usually if you put a number in there and it goes exactly half or exactly twice as far, if it goes exactly twice as far, you can, I like to leave the dip switches alone because it's so much easier to change it in the software. You know, if you go twice as far, just reduce the steps per rev by half. If you only go half as far as you need to go, then double the steps per rev. And then when you run this test, you'll look and you go, yep, that looks right there. So now you've got at least the basic settings correct, and you're in the ballpark. So that is something that you need to do, because again, if you say, well, let's fire it up and run a test part. Well, you run something, and I see this all the time. I see people say, well, I tried to run something that was 10 inches and it come out 5, or it came out 20, or something like that. So that's a quick way. It only takes a minute to lay a tape down there, tell it to go. If you're not sure about how to use the MDI command, it's really simple. But even if you're not sure, you could still just use the arrow keys and jog it and try to stop it. Look at the DRO. Like I'll try to just jog it here with the left arrow. And so you can just bump it like this if you're not sure about, I'm saying this because, you're new at this. So, okay, there I'm within 12 thousandths of being on 0. So you can just jog it that way, and still that'll let you know whether you're in the ballpark or not. Okay, let's see. How am I doing on time here? All right. Once you have those things set, and now you're thinking, okay, I got that fixed. I got it reversed. It's running the right direction. Now it's running the right speed and the right number of steps. Now let's run a part. Well, hold on. Probably still need to run a test part. And if you look over here, let me make this bigger. This is just a simple little test part that I've been using this program for years. It's just a 4-inch by 4-inch thing. It's got a 3/4 inch square with radius corners in the center. It's got a 3/8. I should be pointing over here. Yeah, you can see that. It's got a 3/8 hole up here in the upper right-hand corner, and it's got a 1/2 inch hole in the lower left-hand corner. It's got a couple of radius on half of it, and the other 2 are squared off. It doesn't really matter. You don't have to use something like this, but you can draw something similar. And when you cut this, you need to try to use something to measure it accurately, like calipers. Because if you're just trying to measure with a tape measure, I could give a tape measure and a part to 3 different people, and all 3 people probably have different measurements. It's how you look at it, the angle, and all that. But calipers usually don't lie. If you look at it straight on, put it on the part. But anyway, I ran one of these parts earlier. Ooh, excuse me. I got to add more water. Okay. So I ran this part, and just at a quick glance, this doesn't look like the best part, because let me swap this view again. Because when I look at it straight on, the holes don't look like they're really round. They look a little funky. And you'll notice that I wrote on here, now you don't have to do this because I know that the 1/2 inch round is in the lower left. So, but if you that's why you want to put different holes. You don't want to put the same hole up here as you do here, because then when you pull it out, you'll forget which way it ran. So mark it before you pull it out if you have to. So I know that this way is the X, this way is the Y. And with this one little bitty part, you can learn a lot about your machine. One, you can check those hole sizes and see how close they are. You can check your X and Y here to see if that's 3/4 like it's supposed to be. This one's supposed to be 1/2. The X direction's here, so you can measure. Now, if you put tabs on these, make sure you try to stay away from where the tabs were, because that'll throw you off. But you can check and see how close you are to 4 inches there along the X. You can put it this way to see how close you are along the Y. Another neat thing you can do with this little part is if you have a machinist square, I don't have one, but I have this little square here. You can check for squareness. Again, make sure you're not hitting the tabs. So you want to make sure it's square. There, hold it up to the light like that. And you can also, and this is probably something a lot of people don't do, you can also put this square this way and hold it up to the light. And what would that tell you if you're checking to see how square that side is? That's going to tell you how well you're trammed. I mean, it's a small piece, so it's not foolproof, but I'm just saying, if it's off very much, you're going to be able to see some light when you hold it up like that. So that will at least tell you, oh, yeah, I can get all these other adjustments done, but I'm going to need to tram it. And I'm going to talk about tramming here in just a little bit too. But anyway, so that one wasn't that great. I ran another one. And one reason why this one came out really crummy is because I had sped up the program and made it do just a couple of passes and real aggressive cuts. Because the reason I did that is so when I show it on the screen share, it doesn't take forever. It runs pretty quick. But I forgot that, and when it started running this, I'm like, yeah, I'm probably going to get some deflection and stuff out of that. So this one wasn't that great. So I ran another one. You want to slow it down, run conservative. You're not, this isn't a race. You're just trying to get a part to be able to check the accuracy of your machine. And this one come out a whole lot better. It's still a little off, and we'll need some calibration, and we'll talk about that here in just a minute. But the holes are round. The holes are off a little bit, but they're off the same both ways. So that tells me that the calibration is probably going to fix that. But again, when I check this with the square, I see no light through there. So it looks like the tramming's pretty good. It's pretty good that way. So all in all, that's pretty dadgum close for just firing up your machine for the first time. So when you get ready, when you say, hey, let's run a part, this or something similar should be the first part you run to check. Okay, Paul's already getting ahead of me here. He says, what do you tweak if, say, it was cutting one side an 1/8 or a 16th off? Well, hopefully you're not going to be off that much, because that's way off for this type of a build. But we'll go ahead and let me flip this around again. And if I measure where I wrote the X dimension here, remember this is supposed to be a 4-inch square. So if I come over here to the settings and I click steps per unit, and it's going to ask me to pick a axis to calibrate. So we'll go ahead and start with the X, and I'll say, okay. It says, how far would you like to move the X axis? Well, I wanted it to move 4 inches because that's what this is supposed to be. So I say 4. I don't know if you need to put the zeros in. Okay. And it moved. Okay. So now when it says how far did the x-axis move, see, I'm not worrying about measuring that. I've already got a part. So I said, well, I want it to cut 4 inches. So I know that this is, let's see what this actually is. It really wasn't that far off. Okay, I've got, just to be sure, let me grab my glasses. Okay, I'm showing about 4, we'll call it 492. Or no, I'm sorry, not 492, 392. So I'm going to say that when I did that, it moved 3.92. So it was 8 thousandths under. And then when I click that, you'll see that that Mach 3 will automatically adjust the steps per, and you can accept it or you can say no. So I'm going to go ahead and tell it to accept that. And it says the x-axis has been set. And now when I come down here to my motor tuning, you can see it's got some number right here in the steps per, which that doesn't look right at all. Because it shouldn't be that. Did I do something wrong? I think I did. Let's do that again. Unless it's because I didn't have it zeroed. I don't think that matters. Let's do this. We'll do this. Back here to settings. Hit steps per. Okay, so well, let me go back and set this to what it started out as. Oh, you know what? That probably wasn't too far off because it was a 12.8. Save access settings. Okay. So, yeah, I was thinking 6400 because that's what I changed. So I'm wrong. Yeah, so it wasn't that far off. So you come back here and you would hit steps per. Tell it the X. Tell it to move 4. And then when you measure what it actually cut, I said it was 3.92. So I put 3.92. And then it's going to change it to that value. So you would do this for each axis. You know, you do your X, your Y, your Z is a little different, but do your X and your Y. And then you would rerun another one of these, and you should be much closer. And in fact, your holes should be much closer. All this stuff will be much closer than when you first started. So if it wasn't so loud, I would run another one. But anyway, yeah, that was, I don't know what I was thinking. I was thinking 6400, that's way off, but it's only a difference from 12.8 to 13.061, so that's not that much. Yeah. Okay, so once you've done that, then you might want to think about running a real part. But again, if you're still like a lot of folks that get a little nervous about pushing that cycle start button, just remember that if you've got a program loaded in here, just like I do, this test program, you can always bring it to the spot. Let's say we're going to put this right in the middle of our blank, and we're going to zero out these things here. I've even got the Z zero. And what you can do is you can always raise that Z up the first time. Raise it up a little extra. Hit 0 here. And then when you start this up, you're basically, you don't even have to turn your router on. You can watch, make sure it's not going anywhere. The other thing you can do, I talked about last week, is come to the Toolpath and look at your program limits. You can see that this was programmed from the center of the part, and it's it's only going 2.135 on each side on the X, same thing on the Y. The Z, you can tell from this that it was zeroed at the top of the material, because now the maximum is 0.51, which is, this is half-inch MDF, so it'd be 10 thousandths past. So don't forget about that program limits thing on this Toolpath screen. That's a handy thing to do a quick check and see where you're at. And then you won't have to worry about hitting the button and having to jump and hit the emergency stop or the reset button because it's going somewhere else. Just make sure that when you line it up to where you want to start, make sure you don't forget to zero. That's probably one of the things that a lot of the newbies forget because they're so anxious to watch it run. All right, I'm not going to let that go the whole way. Okay, have I mentioned? Let's see here. Okay, I hope that answered your question, Paul, about, like I said, hopefully you're nowhere near that far off. You shouldn't be. Patrick's here. How you doing, Patrick? Let's see. He says, I've seen mentioned a few times lately on Facebook group folks doing test cuts with a profile cut. Can you clarify these accuracy tests be profile outside, on, or inside? Well, yeah, I mean, again, when I look at this and I come over here to this Toolpath, you notice that this is supposed to be a 4-inch square. And you notice that it says negative. The farthest it's going to be on the negative side is 2.135. And the farthest it's going to be on the other way is 2.135. So if you add those together, that's 2.270, right? And I'm using a 1/4-inch end mill for this program, as you can see, right. Yeah, I'm using a 1/4-inch end mill right there. So you might say, well, where's that 70 inches come from? Well, the reason it's over like that is because in the program, and let's see if I can pull that up real quick. I'll bring this over here. This is it. You'll see that when I did the profile, I was telling it to do a separate last pass with an allowance of 10 thousandths. So that's why there's 10 thousandths more on one side and 10 thousandths more on the other side for a total of 20 thousandths. That's why that number, when you add those 2.135, you get 2.270 instead of 2.25, which is what it would be if if you didn't have this allowance in here. So that's why that's there. But you can really learn a lot about your program just by taking a quick glance at this program limits. Like I said, I mentioned I think I mentioned it last week, and I always do that. Mostly I'm not too worried about the X and the Y because I've been doing this a while. I'm pretty good about not running it off the table or something, but I always check to make sure when I look at this, I can say, oh, well, I need to set the 0 at the top of the material. Or if this says negative 5 thousandths, and I go, oh, I need to set it at the machine bed. You can tell right there. So oh, I said 3. Yeah, you're right. You're right. Okay, so that number is not going to be right. Well, let me go fix that real quick then. I'm glad I'm keeping you guys on your toes here. I'm glad here. Okay, so let me change it back. We'll go back to the 12/8, which is what it was. Now I'll come back to this settings page. It's steps per inch. We're going to do the X. And I want it to move 4 inches. And I'm going to tell it went 3.992, which is 8 thousandths. Yeah, that would have been 80 thousandths. So no wonder that number changed a lot. Okay, so now you see it's 12.825. Yeah, so it's just a little more than 12.8. Yeah, I'm glad you guys caught that, because when I went to run the first part after playing around, I'd probably forget to change it back, and I'd be going, what in the heck? So yeah, glad you guys caught that. Thanks. Who was it caught that? Chris, I guess, or somebody. Thank you for catching that. I make these mistakes on purpose just to see if you catch them. But anyway, all right, let's talk. I'm running out of time here. I got to do this quick. Let's talk about tramming real quick. Like I said, when you do these tests and you use your little machinist square, let me get this back up here. That's going to tell you, because if it's, I'm going to exaggerate and hold this up to the camera. If you're like this, you're like, oh man, my tram is way off. And of course, you can also tell by which side it's off. If it's off on this side or this side, then it's slanted that way. But if it's these sides, then it's either a nod or whatever you call the opposite of a nod. But usually what you have is a nod, because of the weight you put on there, it'll kind of tilt down a little bit. In fact, you guys can't see it, I don't think, but right here, there's an 8/1000 brass shim sticking out that I've loosened these up and stuck behind here just to get this thing to kick back out. But another thing I want to talk about tram real quick is, especially with a Gatton, if you're building a stock Gatton, and you notice I got an aluminum plate here, the router plate that goes on this is 5 inches wide. This front of the Z box is also 5 inches wide. So if you've done a good job setting all this up straight, like you should have, and you flush that up, you're going to be pretty good. You may not even have to bother tramming that way. Now, a good way to check this, and there's lots of good ways, but a really good way to check it without even using any fancy gauges or any of that kind of thing. And I'm going to share a link, and I'll put it in the description after I get done here. But I've got it somewhere here. And this is a video that Gatton CNC put out. And it's really a good video, because it talks about leveling, squaring, and tramming your CNC router. But the reason I'm going to show this link is, share this link, is because it applies to any kind of CNC, and especially the tramming part. If you don't want to watch the whole video, the tramming part starts at about 7 minutes in, but it is an excellent video. It shows you how to put a tool in your, let's see if that works. I think it will. And I'll come over here and put it on Facebook too, because it's let's see here. All right, come on, everything pokey now. I don't know if that's a Facebook thing or a Dave's old computer thing. Well, there, that's copy sessions. Come on. You can do it. There we go. So I'm gonna put this in here. So there's the link. Like I said, I will add it to the description of this video as it becomes a YouTube video. And it's an excellent video showing you how to eat, because you got to remember, a lot of people say, well, I got everything done, but I got to tram it. You may not even need to tram it. You need to run tests to see if it needs tramming before you just start doing it, because depending on how you do it, it's going to take a minute. But this is basically showing how to take tools, and they run pockets. They run one where it's going back and forth in the Y direction, and then you check that to see if there's any smoothness. And you also have to remember, if you're using, especially if you're using MDF, It's kind of like when you cut the grass. When you push the mower down this way, and then you turn it around and come back right next to it, you see a different line, but it's the same way with MDF. It looks like you have a lip, but if you take your finger and feel it, it's smooth. So don't be confused with what looks like it's off with a real step. If there's a step there, you should be able to feel it. So you run that program one way, check it that way, and that'll tell you if you're off this way. And then you can turn around and run that pocket the other way on the X direction, and you can tell if you have a knot or not. So it's a good video. Check it out. And that's but like I said, don't just automatically assume you're going to have to tram, because it might be like with mine. It was a simple. It was fine this way because I flushed everything up with what I had, and even when I did this, I had to adjust it a little bit because I couldn't use the flush trick anymore. But as far as the knot and stuff, I found an 8,000 shim behind the bottom, the lower part, to kind of raise it out a little bit, and that was all I did. So, so yeah, you want to get that set right. You have to surface the spoil board before tramming. You can, but you're still, if you do that pocket thing, you're still probably going to be able to tell whether you're off or not, whether you've surfaced or not. So go check out that video that I posted a link for. It's really good. And like I said, if you don't want to watch the leveling part, because they're basically showing you how to level the frame of an Avid, so that part may not apply. But the squaring, they got a real neat program showing you how to square to make sure your gantry and all square. And of course, they're adjusting these photo cells. Their switches are all those type. Proximity switch is what I was trying to think of. So you can adjust those to get the gantry square on that. And you may or may not have something like that. But still, if you've got mechanical switches, you still need to make sure that they're tripping and doing the right thing, because you don't want them set and tripping, but want them still maybe kicking out a little bit. So that's a good video. You can learn a lot from the methods they use. So all righty, I think I'm at 46 minutes. I want to thank Paul for writing in and asking to do this. We've had a pretty good little group of folks over here. I hope y'all get something out of this. Yeah, Eli says if he surfaces before tramming, you might have ridges on the spoil board. Yeah, true. And like I said, since this method uses the pocket, it doesn't matter whether you surface it before or not, because you're going to tell if you got a step when you do that pocket. You got to do it both ways though. Run them along the X and then run them along the Y on a different spot, and then feel it. Okay, I guess that's it. Thank y'all very much for watching. If you got anything out of this, leave me a thumbs up or subscribe, or you know the drill. Share it, all that crazy stuff. And if anybody, like I said, if anybody has a question or something they'd like to see, just shoot me an email. You know where I'm at. Let's see, I think I got, well, you can go here. That's the website. Just click on the contact link and shoot me an email and say, hey, show me how to do this or whatever. Now, one more thing, and then I'm going to get out of here. I know I'm running long. I mentioned during the very first one of these that I did that I was going to be doing another one of those where it's just a board, piece of plywood, and I was going to put power supplies and drivers and breakout boards or motion controllers or whatever, and show some just kind of a basic wiring thing. But the problem with wiring is it's not a one size fits all. Everything is different. So I've rethought that, and I've already started working on it. I've already got some drivers, some power supplies. In fact, they're already mounted and stuff. But I'm going to start out with a USB motion controller. Let's see if I can hold it over here. Like this. I'm going to start out with this one, but I think what I'm going to do, I was going to try to pick something that's the most popular, but I thought instead of doing that, I will get different ones, because basically the drivers and the power supplies and all that, the main electrical, the 110 coming in, all that's always going to be pretty much the same. So what I'll do is I'll buy different things, and then we'll do a show or a video with showing how that's wired and how that particular board works. And then if somebody says, hey, can you show me with such and such, I'll get that one. And what I'll do is when I'm all done with a show or a video with a particular board, we'll just do a giveaway on it or something. Because I don't need all these things. But that, this is, most of these are fairly inexpensive. There's a few, when you get up to the UC 400 and stuff like that, where they start getting a little bit pricey, the smooth stepper, that kind of thing. But still, we'll try to do that demonstration board, that kind of a basic wiring thing, and we'll do it with a bunch of different, like I said, controllers and or breakout boards, that kind of thing. So you can look forward to that. And let me look real quick. I don't see any other questions. I think we're going to call this one done. So thank you all again for tuning in. I appreciate it. Sorry we went a little bit long, but I should have turned that off a while ago. That makes a lot of wreck. But, every Wednesday, 3 p.m. And if you want to see something, send me an email, let me know. Otherwise, we will see y'all next week right here. Everybody have a good one.